Today's topic is called translations. This is a new transformation, and you can use the date of April 23rd. This is the note packet that you'll need for today. There should be 4 pages to this note packet. All right, let's start with the definition of a translation. So basically, we're going to take our original figure and we're going to move each point on the figure the same distance, and everybody's going to go in the same direction. So when you look at it graphed in the coordinate plane, it will look like you slid the object over. So it does have a nickname of a slide. We have 2 types of abbreviation. The first one is the one that most people enjoy. It's very simple. We use capital T for translation, and the rule on how to move the object is listed in a subscript. Don't put parentheses around this. This is not an ordered pair. It's directional left and right or up and down. The second abbreviation is something you might have seen in 8th grade when you're introduced to transformations. So basically they're saying take your generic point, wherever it's located at XY, and it will map onto, and we're either adding 3 to the X, and then we're adding 4 to the Y. But the rule can obviously be different. We could be subtracting as well. When we translate, we're going to follow the rule that's described in the problem. So what we want to do is start with the coordinate grid. We know that the x-axis is horizontal and the y-axis is vertical. So knowing that the first value listed represents our x quantity, if you take your x value and you're being told to add some amount, we're sliding it to the right. So the positive numbers on the x-axis are on the right-hand side, so your object is moving towards the right. If, on the other hand, they would like you to subtract or a negative number is present, that means you're sliding it to the left. So we always slide left and right first along the x-axis. Once that movement has occurred, we're going to move along the y-axis. So you'll see that the y-coordinate is changed. If they're asking you to add to the y value, you're being told to move the object up. So we're sliding it up that number of units. And likewise, if you're subtracting or you see a negative number present in the rule, we're moving the object down. So we'll make one movement left or right, and then we'll make one movement up or down. We're going to start with example 1. So we're going to plot our triangle HAM using the points that they've provided us. And there it is. According to the directions, we're going to translate. -5 means move it 5 to the left, and -4 means move it 4 down. So this is our translation rule. So what I've done is I've added some arrows here to show you. So the point at the top of the triangle is going to move 5 units left and 4 units down. Every point, though, on the triangle will move in that same pattern. So the second point directly below will move 5 left and 4 down. Same with the one over here on the right. So the rule says -5, -4. This one's very easy to work with. It's simple addition and subtraction. So on H, the x value is 3. We're going to subtract 5, and the new x coordinate is -2. On H, the y value was -1. We're going to subtract 4 to come up with the new value of -5. So when we're applying the translation rule, all 3 points go 5 left and 4 down. So this is the location of A prime and the location of M prime. So when I finally graph my image, there it is. So the figures that are present are identical. They're facing the same direction. Everything about them is exactly the same. In example 2, our figure is a quadrilateral mope. So we'll go ahead and we'll plot that figure. Looks like a trapezoid. Now we're going to translate it using the rule 4, -6. So this tells me I'm moving it 4 units to the right and 6 units down. I'm going to go ahead and apply that rule to the existing ordered pairs. Don't forget you want to complete a full mapping. That means list all the originals, state your rule, and then your prime location. So I took -4 and I added 4 to get 0. And then I had 6 minus 6 to also get 0. So we're going to add 4 to all x coordinates and subtract 6 from all y's. This is my new location of O prime, P prime, and finally E prime. So now that I know the locations of the prime image, I'm going to go ahead and plot that. You should see a congruent figure, and that's exactly what I have. So we basically took the figure and we slid it over and down. Congruent. If it's not congruent, you'll know something's wrong. In example number 3, we have triangle RST. We're going to translate it using this rule, 0, 5. Now the use of the grid is optional, so I'm going to opt not to use it because the rule is a simple addition and subtraction. So if I'm adding nothing to the x coordinate, that means all these x coordinates are going to remain the same, but I am adding 5 to the y. So there's R prime, S prime, and T prime. If you would prefer to graph it, you are welcome to do that. You'll just want to make sure that everything you put on the graph is accurate, because once you start graphing, it's eligible for grading. Now, we're going to find the rule of the translation that has occurred when I move from B to B prime. So B prime we know is the image. So using this setup, we want to know how many units to go from -2 to +4. And then also how many units to go from +10 to +6. So for the x coordinate, it looks like we're adding 6. And for the y coordinate, we subtracted 4. So this is the translation rule that applies to this first example. For our second example, take a minute and see if you can identify what's happening between x and y. So for x, we went from 0 to 4, so it looks like I'm adding 4. For y, be careful. If you can envision the number line, we're at -7 on the y-axis, and we have to rise all the way up to +6. So that's a positive move of 13 units. For example number 3, we're going to use the other abbreviation. So if you look what's happening between x and then y. So I have my generic ordered pair, and I'm adding 1 to x, and I'm adding 6 to y. We'll use the same type of abbreviation for example number 4. So it looks like x is remaining the same and y is increasing by 1. So this is the way I wrote it at first. I did show x plus 0 and y plus 1. You don't have to show x plus 0, so another option would be simply stating x and then y plus 1, but both are acceptable. And you can use either the t or you can use the x plus 1, y plus 6 setup. Now we can look at an image and also come up with our translation rule. You can select one point to focus on. Maybe we focus on A, and we want to move left or right. And it looks like my figure is moving to the right. So we have 1, 2, 3, 4, 5, 6 blocks to the right. So that's a positive move. And then down 1, 2, 3, 4. So my translation rule is going to be +6 and -4. For my second object, again, you only have to select one of the vertices on the original. Maybe it's point G. So we want to move left and right first. And I'm going to have to move left. 1, 2, 3. So that's negative. And then I'm going to fall. 1, 2, 3, 4, 5, 6. So it looks like the translation rule is -3, -6. Let's go through some of the properties that a translation will possess. So remember we said invariant means it doesn't change. So the first thing, the size of the figure, the pre-image and the image are going to be exactly the same. So the size of the figure is preserved. The shape of the figure is preserved. If you graph the pre-image and it looks different at all, that means there's a mistake. So visually, I should see that they're identical. We know that angle measure is preserved. If you're producing a congruent figure, all angles must be the same as the pre-image. The distance between points is preserved. So the distance between point A and point B will remain intact, and the distance between B and C will remain intact, and so on. Any sides that were parallel or any points that were collinear on the pre-image will remain parallel and collinear on the image. So that is preserved. So since all of these properties remain unchanged, we can conclude that when you perform a translation, the pre-image and the image are congruent. So a translation will be classified as an isometry, which is a rigid motion. Basically, I grabbed it and I slid it to a new location. Thinking about all the diagrams that we did in these notes, when I grab it and slide it to a new location, the figure is facing the same direction, and all the ordered pairs or the labels on the vertices should be going in the same order as well. So this will make it a direct isometry. We are maintaining its orientation. This is homework number 117. There's only a front and a back. Make sure you do a full mapping for number 28 and 29. And in some cases, you'll have to build on. So once you create triangle HOT and then triangle H prime, O prime, T prime, you're going to build off that prime image to get a double prime. So this will be something that's a little bit new, but you just keep building off the one that came before it. If you have any questions during this assignment, make sure you contact me in some way, and then submit your assignment as a PDF as soon as you're finished. Have a great day.